Hey everybody, in this final video with new material, I'm going to show you how to evaluate the relationship between two numeric variables together. And we primarily do this when our variables are both ratio level, but you could do it with any continuous variables. So I'm going to start by putting in our script, a notation, and we're going to say look at the relationship between two numeric variables, and we're going to use a function from the Hmisc package to do this. So I'm going to put a notation here as well to remember to require Hmisc package first. So as with every other relationship that we explored so far in this class, we first plotted those relationships either in a histogram, a bar plot, box plots, or something like that. So we're going to actually start with what's called a scatter plot. And what it does is it plots each observation on both variables. So to begin, let's look to see if there is a relationship between patient's age, and we mean the actual age variable, this variable where we calculated people's actual ages and their length of stay in the hospital, because we certainly have seen higher lengths of stay for some patients as well. So the function that we're going to use here is plot. And you just in parentheses put the two variables. So I'm going to say age. Now it's not the age cat or age 8, it's just age. And we're going to put a comma and LOS. And it doesn't matter, by the way, which variable goes first in this plot. And when we run it, oops, I didn't hit run, I hit enter. You'll see that we have, as we had seen with length of stay, a lot of clustering at lower ages. See, this is patient age, and this is length of stay. Now, again, we can annotate this with main labels, x-axis labels, and y-axis labels. So for this purpose, why don't we just put in a main label equals patient age and length of stay. But you can annotate these exactly the way we have done this in the past. For length of stay, you would possibly want to put in days, so to indicate days. But for our purposes, for this, we see that this is, we see a lot of clustering. So for instance, we have a patient that is just under 70 years old who had a length of stay of 70 days or something like that. So each person is represented here, and obviously if you have patients of the same age and length of stay, those would be overlaid on top of each other and would come across as darker circles. So that plot function provides us with this scatter plot here. And now we want to actually look to see what the correlation is between age and length of stay. I'm thinking that it's not going to be super high because it doesn't look linear really much in any fashion at all, but we'll check it out. So we have the Hmisc package required, so we can use the rcorr function, which will give us some extra output that you're going to find helpful. And we do exactly what we've done before. We'll just go age, comma, length of stay. And when we run this, I think we didn't require that package. So let's go into, say now here's an error that we saw. I couldn't find the function, And I know that rcorr is a function in Hmisc, so the only thing I could conclude is that I hadn't required the package. So now it's going to load the package, and once that stop sign disappears, we can just rerun that. Okay, now remember that we have 161 patients in our sample, and I'm going to go back to the plot so you can see this. So what it tells us on the X variable, which is the age variable, we have information on 155 patients. That's the XX combination that we have here. The YY combination tells us how many observations we have on the length of stay variable, which is 161. And we knew that we had all the information on length of stay. But in order to calculate a correlation, you have to have information on both those variables. Otherwise, you can't plot this. So we know that we have 155 patients. Now, we could actually have less than that if we had less on the Y, because you could have missing data on variables, on observations, that, you had all the age, but you didn't have all the age, you didn't have all the length of stay, but they weren't necessarily for the same people. So, but here we have, since we have everything on length of stay, we have 155 total observations where we have both the X and the Y. And for each of these, you're going to look at the intersection of X and Y in these three little grids. So we have 155 little circles here. Now, the correlation between the X variable age and the X variable age is 1, because age perfectly predicts itself. Same with length of stay. So in any of these correlation matrices that you will see, you will always have on a diagonal the variables. You'll always see a 1 because it's the correlation of any variable with itself. What you're really looking for is that XY combination, which is the correlation between age and length of stay. And here it's 0.25, and that is a weak correlation, and that's why we didn't see anything too linear here. We just saw a lot of clumping all the way up through from age 65 to 80 at these very low levels. And once people start getting a little bit older, their length of stay gets a little bit longer, but it's not particularly high. And we see these highest lengths of stay. You have one patient that's in the 87-ish range, and one that's probably 75 or a little bit above. And this last section here is the statistical significance section, as we see by P. So, if we replicated this, 100 times or more, what would the chances be that we find these results or something more extreme? Meaning, how unusual is this? And it's pretty unusual. The relationship is, their chances of making that type 1 error is 0.17%. Now notice that this is a statistically significant finding even when the correlation is low. So you can have low correlations and statistically significant findings, and as well high correlations that are not statistically significant. Remember, sample size plays a role in this, and all we're talking about is the strength of the relationship between age and length of stay. So age is a significant predictor of length of stay, but it's a weak predictor. So I'm going to show you 2 more examples where we get other bits of information here. And I wanted to continue exploring that idea of length of stay without regard to age, but thinking about those activities of daily living. So we'll talk about those instrumental activities of daily living. And again, you should refer to your book, but it's talking about, people being able to drive and shop and pay bills and maintain a home. So that's our TIADL, mean variable. And here we have that. And we're going to say activities of daily living. and length of stay. And we'll just hit run. Now here we go. It looks different. Now this is looking different because we are on a scale. Now I want to show you the nice thing about correlations is the scales don't have to be the same. So here we both had time elements, but notice that age was in years and length of stay is in days. In our next plot, these are scales. So it's a little bit strange because we have a lower bound of 1 and an upper bound of 3. However, it does give you a sense. It's why it looks like you have these columns here, whereas you don't have that with the age. But it is a reasonable way to sort of visualize this. Now this looks a little bit more linear, whereas when you have these higher lengths of stay associated with lower activities of daily living scores. You do have low lengths of stay for people that have low activities of daily living scores, but those high guys, these are primarily the folks that have lower abilities to care for themselves. And I have a few here, but you can see that you have these dark circles that are just overlaid one right on the other, and that's because you have a lot of people in these upper ranges and many fewer down here. So if we look at the correlation of that, and we put TIADL mean, and we run that. Now, it tells us that we have observations on just everybody for both variables. And the findings are statistically significant. In fact, this only goes out to like 4 decimal points. So this p-value is less than 0.00001. That would be rounded to that. So our p-value is, again, it's never 0, but it's very low. But now we have a stronger relationship. In fact, we have a negative relationship. That means as activities of daily living scores increase, that's more independence, the lower the length of stay. And that makes sense. Sometimes you get findings that are counterintuitive, but not in this case. And notice that this, sort of the order and the linearity of this looks more orderly than what we saw here when the correlation coefficient was 0.25. This is higher. Remember, we have both magnitude, which is that negative relationship, and direction. So it is a negative relationship, which is fine, but the magnitude is 0.53. So this is a more moderate relationship. And now I wanted to show you something that was just, a much stronger relationship. So we're going to keep this TIADL mean. And look, so remember, those are activities of daily living, like I said, like bill paying and grocery shopping and stuff like that. We're going to look at the TCAT sum as well. So this has to do, again, with really caring for oneself, like toileting, getting up from a chair, feeding oneself. So we're going to change our main level to activities of daily living measures. We'll just make that our. So the question is if you're strong on one, do you tend to be strong on the other? We would think so. So now we see something even much more orderly. And again, notice that some of these circles are darker. Like this is a darker one. This is a darker one. But this looks like a stronger relationship. And when we go back to, the actual, so I'm going to suspect that our correlation is higher than what we saw of that 0.53. And notice, by the way, now this looks like it's sloping up. So this should be what we should see, a positive relationship, I would think. As one increases, the other increases. So we had, you could look at it but it was TIADL mean before. Let's do TCAT sum here. So we're putting in the same material. And here we're missing information on the TCAT sum for one of the patients. We knew we had everything for the TIADL mean, but we don't have it for the total for the patients. And this is scaled differently. Again, remember that this is the sum of those items. This is the mean of the items. That's okay. But now look at the relationship between these two variables, and they are quite high. So for most people, we could assume that, you know, if you're good at taking care of your body, you could also probably manage your household as well. So that's the illustration of this. I hope you found this helpful. And yeah.